All right, so hello everyone, and welcome to another live session. And this time we have a different guest and a very different topic from the rest of the live sessions. And yes, you can already see the name of the live session in the chat. But before we move forward to the session and we start with this interesting conversation, I can see that you guys are already live. So, in case you can see me, in case you're excited for this live session, please go ahead and write anything in the chat. You can go ahead and write yo, boom, any emojis whatsoever, excited, anything, so that I know that the numbers on my screen are not lying. And yes, these are the people currently watching this live stream, and you are able to see me and hear me all fine and all right. All right. So, okay, so I can see that a lot of you have already tuned in, and we are waiting for comments as well. So, by till the time you guys are writing, okay, thank you so much. I can see the first comment, and there is a lag. Yes, I know. So, no worries about that. So, let me pull up our special guest for the day, our special guest for the evening, who is none other than Mr. Ronaldo. All right. So thank you, Mr. Ronaldo Laishram, for taking out time from busy schedule and attending or agreeing for this live session. So please allow me to introduce you to our audience. So Mr. Ronaldo is currently enrolled as a PhD candidate in astrophysics at the Astronomical Institute of Tohoku University, Japan, having completed his master's degree in the same. His area of research lies in the study of formation and evolutions of galaxies, including the environment and morphological features of galaxies. He has also worked with Space Physics Laboratory in Vikram Sarabhai Space Center of the Indian Space Research Organization as a research fellow while attending several international workshops. And in this particular session, we'll be learning about the JWST mission, space telescopes, and the relevance in the interesting field of space exploration. So that is Mr. Ronaldo for you all. And yep, and once again, thank you so much for this live session, and thank you so much for agreeing and going ahead and explaining about the JWST and all this. What does all this mean? How can we understand the universe? And yeah, thank you for that.
Thank you so much, yeah, for inviting me for this talk. Yeah, it's really nice opportunities to share this journey of JWST with the with my fellow people. So thank you so much.
All right. So thank you so much. And yeah, before we go ahead with the live stream, I'll first like to ask you that currently where you are, and what is the time there currently?
Yes. So currently now I'm in Japan, like it's in Sendai. So the time is now 9:40 p.m. So it's like 3.5 hour like difference from India. Yeah.
All right. So when you're planning back to come to India, don't you miss India?
Yeah, I recently visited India like in
Oh,
February last week, last this year. So after 2.5 years. So unfortunately, I may not able to come back until my completion of my PhD because I'm going somewhere like yeah some other countries for my work also. Yeah, let's see. But I would like to come. I miss my family. Yeah, my friends.
okay, so looking forward to come back and come
Yeah.
looking forward to you come back to India. And all right. So okay. So you have or you are currently in this sector, but yeah, I think the audience would also like to know that what has been your journey in the space sector? I mean, how did you step into the space? What was the first thing which inspired you and which has brought you to this entire realm of astronomy? I think you can go
Yeah.
ahead and description about that.
Yeah, actually, it's like my journey is kind of interesting because it started when I was 6 years old, like when I was very small, because I'm from like Manipur, like it's northeast part of India, and so I'm from kind of countryside. So we have like we when I was kid, we used to play with my friends like around 6 year old. So in the dark in the evening time when we were playing like running and the catching. So I fell down actually, and when I fell down, I saw one very bright object in the sky. But that time I didn't know. I don't know like what is a star or anything because I was too small, and so I was wondering that time like. what was that? I mean, how is there not in the surface or something? Why is in the sky? So after that, I kept asking like my parents, my brothers, my sisters about that, and this is how like that star that it inspired me like so, and I fall in love with astronomy. So after that, when I went out, I always keep looking for the stars, looking the sky, and till now I'm looking at the night sky. So and after that I started like learning about this astronomy, and I started asking like kind of questions. So I will get back that three questions in my slide. Will be interesting question. And yeah, this is my journey. And I took my I completed my high school higher secondary in Manipur. Then I went to study like BTech in computer science engineering. And that time my field is kind of different. Like computer science and astronomy is kind of different field. And I so that I kind of done the job after my BTech, but I thought of following my passion. Like I don't want to give up because and I love this subject astronomy, and I don't want to give up. So I converted my from computer science to I jumped to the astronomy, and yeah, this is how I came to Japan by applying this scholarship, and yeah, this is journey, and now I'm doing what I love. I'm trying to understand the universe, trying to understand the galaxy, hoping yeah.
Okay, so well, thank you so much for answering that question. And yes, it was indeed quite inspiring that how the night sky guided you to this sector, right?
Yeah.
The night sky, legit, the stars. So you follow the stars, and yep, there you are currently. Okay, so well, that was quite inspiring, and yep, thank you so much for that. And all right, so coming back to the main topic of today's session, that is understanding the universe with the JWST images. So, as we all are aware of the images, the marvelous, the fantastic images which has been released by JWST. So, I'd like to first know that what was your first reaction when you saw the first images of JWST?
Well, actually, I was waiting for that moment. Like I didn't. It was in the night. I didn't sleep, and when I saw the first image, like I cannot keep away my eyes from that image. I'm too excited because it was the first time we like humankind we ever seen this kind of image, and I don't know how to explain it, but it was so surreal. Like I I cannot sleep. I that night I stay keep awake and whole like not only one day, 1 or 2 days. So I started playing with the images. I do the coding, to play with the sounds with the images. But some yeah, because I was too excited, and it gives like it inspire us a lot because no one expect those kind of image like deep into the universe, like very far deep into the starting of the universe. So it inspired us like, and I started keep reading many things because I need to read to update with the new knowledge. So it inspired me, yeah. And it's still I cannot get over with the images.
All right. So yep, we all know the images of JWST which were released, and that brings us to actually the topic of this session, and that is understanding the universe with JWST. So, Mr. Ronaldo, can you please go ahead and explain that through this JWST images, how do we actually, understand the universe?
Yeah. So okay, all right. Yeah.
All right.
So I will share my slide so that it's easy to understand for those who are watching this webinar. Yeah, if you see the slide, actually I make this slides so that non-astronomy, like people from non-astronomy background, can easily understand. So I skip the mathematics and the physics, like advanced physics, those things. So if you are working on this galaxy or those things, it may be I don't know. Yeah, so this is mainly for those who are from non astronomy background. Anyway, let's try to understand the universe. Let's try to understand the universe through JWST. And unfortunately, like because of time schedule, I cannot cover everything. So I will just cover something like this is basic. Yeah, and then let's see how JWST images are. So in this, I will go through this. Firstly, our place in the universe is interesting, and we will explore the universe with the web. Then we will be like we will see the exciting discoveries of the web. So before that, as I said before, when I was kid, I was inspired by the sky, and I kept asking myself these three questions, like where we are now. I mean, who am I? Who are we? And are we alone in this universe? So even if you are from any background, you don't need to be astronomy background or to ask this. You can ask, and so this is kind of general question, and yeah, even it will inspire you also. Yes. So where we are now? Let's go. Where we are now? Like so, I mean, some people. I think a lot of people are watching from different parts of in world. But so I'm from India, so I will say I'm from India. Well, where is India? India is in the Asia continent. Then you can ask, where's Asia? Like, oh, Asia is a part of our planet Earth. Then still you can ask questions like, where's the Earth? Well, Earth is it's part of the solar system, and then solar system is also part of the Milky Way galaxy. It's our galaxy. Then where is the galaxy? Where is our Milky Way galaxy? Milky Way galaxy is part of the there are lots of galaxy clusters. So it's one of the galaxy. Then so exactly where we are now, right? So firstly we were in India, and I'm was in India, but now I'm part of this galaxy cluster, super cluster. So everything is like it's the universe. So like everything, whatever you see, whatever it does, whatever you don't feel, like everything is belongs to the universe. So it's very important to understand universe, right? So yes, before going things, I would like you to visualize this, like about the zooming view of the universe is scattered by the Daniel of Rescue. Like yeah, so please this let's watch this and see the beautiful the view of our where we are now. Yes, so she is now in the Google Office and Google Plex. So now we are zooming out. We're zooming out. So wow, now we are in the mountain view of California, Silicon Valley. So yeah, and we were going out. Then yeah, this is our planet. Beautiful. We have this Earth and the Moon. We are now lunar orbits, and yeah, these are asteroids. And yeah, we have lots of other planets, like we have this Jupiter, Saturn. Oh, we see the one telescope also. Now, see, we are now 1 trillion kilometer, going out one light year. I will come to the what is light year later. We have Alpha Centauri. We have Locan bubbles, This is where our, galaxies are located. Oh, this is our beautiful Milky Way galaxy. And we have the satellite galaxy. Oh, we have Andromeda galaxies here, right? So this is my work also kind of related to this thing. So this is kind of clusters, a large scale structure. Okay, we are now zooming in again, coming down. So we were firstly she was in the Googleplex, and as now she's belong to the like this large scale structure. So yeah, this is interesting. Like so now, I think most of you are now like thinking where we are now, right? I hope so. So the thing about this is like even though you don't need to be like yeah, if you are in astronomy or something, you can go to the physics, but you can think it. It's very interesting things to think. So this is the cartoon of our Milky Way galaxy, and this is where we are located in this small region. So the question is that how does we get here? How does the universe work? Right? So before doing that, let us go back to let's before asking this, how does we get here and how does universe work? It is same question is that I'm now like doing my PhD. So if I want to know my origin or something, I mean how I grew up, I need to know my origin, like where I was born and who was my parents and like where did I do my schooling, different things like and how I grow like the stage of growing up, right? So similarly, for galaxies, if you want to understand them, we need to go back from the when it was forming. Like it started when the galaxy was formed, when the galaxy was kid. So how can we know what the universe was like in the past? So we have this, or we know we. I mean, most of us maybe we know that uh, w- we are universes formed from the Big Bang. So Big Bang is the theory like origin where our universe is formed. So there are different things. There are different things that universe. There are different theory that what is before the Big Bang, but still we are not. I will not go into that thing. So I want to study our universe, right? So we will go to the Big Bang, and from here the time is started, like time zero tick. Then we'll go to the coming to our like current time. So at the starting of the Big Bang, then we have cosmic inflation where it's expanding at the very like tiny of the seconds, like 10 to the more 32 seconds. Then we have particles are formed, quarks, and yeah, those things are formed. Then we have this recombination era, like ordinary matters, particles decouple from the light and the cosmic microwave background. Cosmic microwave background is the light, the first light on the unit we observe from the when the universe was formed. And we have dark ages. We have this dark matter, and the ordinary matters fall into this dark matter. Then we have this, and fast stars are formed after 200 millions, like around 200 to 300 million year. While after the Big Bang, so we are now going to the 200 to 300 millions. Then at that time, we have the fast star and the galaxies were formed. Then after that, we have large scale structure are forming, like lots of galaxies are started forming, stars are forming, and galaxies evolutions, like the galaxies are changing their properties, like as I mentioned before. When I grow up, I changed lots of things when I was kid, right? Similarly, when the galaxies, they started changing their properties, and this is we have these clusters of galaxies, hundreds of thousands of galaxies, and the planets like stars are, and we have this from in the stars we have these planets are formed, and the other celestial objects are formed, and then now we are here. So yeah, universe is around 13.8 billion year old. Wow, billion year. How interesting is that? I mean, it's too old, right? But so if I want to study the fast star or galaxies, how will I go back? I mean, we all we human beings, like we survive for around say maximum 100 years, but this is billion year. Then the question is that, is it possible to go back to like 3 or 13 billion year ago, like go? So let's see whether we can go back there. If we want to study how our origin, like galaxies are formed or different things, we need to go back there and see how they're changing. So let's see whether we can go back. Okay. So yeah, as I want to say that our universe is expanding. Like, what do you mean by universe is expanding? I mean, so it means that the galaxies are moving away from us. You know, I'm looking on galaxies, and we have this another galaxies. So it's with the time we are going going away from each other. So for easy to visualize, I have this. We have this Milky. This is our galaxy. This is neighboring galaxy, and this is another galaxy which is twice as far from our galaxy. So as I mentioned, the universe is expanding because of the dark energy. I will not go deep into dark energy because I don't have much time. Yeah. So this is a starting point, initial point. At some time, you see, this is the our galaxy. So those the galaxy which were recited here now moving farther away, and those exciting are moving farther away. But interesting things, these galaxies are kind of two times farther from here, so they are going more farther away. So what we can see say from here is that galaxies are moving away from us, and the galaxies that are farther away, like which are more farther away from us, are moving faster, like they are running away from us more faster. So the universe is expanding, and yes. So as we know, like we we see, right? We all see around surrounding around us. So this is we see only small tiny regions of this electromagnetic spectrum. So this is called visible lights, called rainbow light. So from the violet to red, we only see between these visible lights. So those who are emitting light in radio wave or X-ray or gamma or the like longer wavelength or shorter wavelength, we will not able to see those things. So we are able to see here. So the thing is that when the galaxy they are emitting the light, I mean, because all the moon is emitting the light, the sun is emitting the light, so that we can see them. So when the galaxies are emitting the light, as they are expanding, like as I said, the universe is expanding, so they are running, they are going away from us. So the light which are in the visible, so when they reach us, we it's like the light is stressed. So the thing is that this is the say this is the uh thing. So when this expanding something, it will be stressed, right? So it will be going away stress. So it will go to the longer wavelength. So this is what we see, we say the redshift. And the yeah, maybe you may not familiar with the word redshift, so I will play the animation. And those who are coming towards us, they are called the blue shift. So in order to visualize, say, so let's say it's called Doppler effect. So let's say I'm standing near the road, and we have this one ambulance coming, ambulance siren with the sirens coming towards us. So the intensity of sound is increasing towards us, right? When ambulance is coming toward us, I will hear the more like louder sound. So when it's going away, the frequency is decreased. Frequency is going down, decrease. So we will not hear the proper like silent. So the same thing. So when the galaxy is going away, the lights are expressed and they're going to the more longer wavelength, less energy, because they are going very far, coming from the very far distance. Those who are getting near, their wavelength is like compressed. So we see they are in the blue region, this blue region. So I will play this video. As we see, the galaxies are nearby, they are emitting in blue region. So when they are going away, they are going farther. They are like going up to here, now red. So light are stressed, and it takes more time to us reach us. Yeah, so it means that when an object moves away, the light wave get stressed and move towards the longer wavelength. So yeah, so what is redshift? As I mentioned, redshift is the further away the galaxy is, the redder it appears. So just I mean similar video, but easy to visualize. This is a galaxy here. Nearby galaxy, we will see they are blue because they are very near. Those who are very farther, we see that they are in the red, like longer wavelength. So yeah, so how can we know that, like in the past, so that we know that light travel at the final light is the fastest, light speed is the fastest we ever known, right? Nothing can move faster than the light. So let's see how long the uh, when we see the moon, the beautiful moon in the sky. So say I'm in the earth, my one of my friends, so he is in the moon. So if he say hi to me, then I will see him, he's like see him like after 1.3 second, not instantly. So there is light in my room, so I can see it's very instantly because it's very near to me. But in the moon is kind of a bit farther, so it will take 1.3 seconds to reach the light. And for the sun, so my friend is in the sun, so he's doing high, but the high like sound when it reaches my place, it will take 8.3 minutes. So after 8.3 minutes, I can see him say hi. So the thing is that if the sun is now gone, I mean sun is removed from the sun is gone now. So and we will not know the sun is gone. We will know only after 8.3 minutes that sun is gone, because the light from the sun, it takes 8.3 minutes to reach our planet, our planet. So this is interesting, right? So it takes, because of the farther, more farther and more farther away, it takes time to reach us. So say, let's say Andromeda galaxy, our nearest, our neighboring galaxy, twin galaxy. So it takes 2.5 million light year. Wow, it's too far, 2.5 million. So what is light year? As is in the video, light year is the distance light can travel in 1 year. So light is traveling at 3 into 10 power 5 kilometers per second. So when it travel in 1 year, it's like around 10 trillion kilometers. Is too I mean long, right? So this is the light distance. So the thing is that here the galaxy, so what this is galaxy is that 7 billion light year away from us. So there is one galaxy which is 7 billion light year from us, very very far, right? So here my friend was there, and his spacecraft is not working. So he sent a signal to us like, my spacecraft is not working, and I would like to repair it. But the message that's like, when the message, when it comes, the light message, when it comes from the galaxy to our galaxy, it will take 7 billion light year. So when we receive that image, we will observe those, when we receive those things, we will observe that at before 7 billion light year. So how this is how we observe the galaxies, very 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 old galaxy, I mean distant galaxy. And so this is how we build a telescope. Sometimes you may heard telescope is kind of time machine, right? So telescope are the time machines. So this is how we observe our distance, like all, yeah, distance when the universe was formed earlier, and how our fast galaxies stars are formed. So this is how. And yeah, so now coming to the point. So now, uh, even though the universe is 13.8 billion year old and is expanding, so we can study the fast star, fast galaxies, fast recombination area with the help of a telescope. So we are going back to time. So because uh, here the light from here, it takes, when it comes to our, it will take like, when the first star or galaxy was formed, it emit the light. So when we reach there, it will take 13 billion year old. But when we observe that, and we can study the fast star, right? Because that light is from the, not currently from that galaxy, that was from when the galaxy was born. So yes, this is how that, as telescope is time machine, and we need telescope. We need more telescope to study the galaxy, to study stars, to study many things. So we have lots of telescope. We have in the ground, and we have space telescope, and yeah. So these are the some of the telescope here, uh, and I'm not including JWST here. So I will come to JWST for separately. So these are they are observing a different, like, they have their own jobs. Like this telescope are observing gamma ray, like high energy, and these are low energy radio, microwave, Planck microwave, and the Hubble telescope are visible. So this is how we try to understand its spectrometric spectrum, electromagnetic spectrum. So yes, so now, as I mentioned, so Hubble telescope, as many of you heard, Hubble telescope was launched in the space in 1992 or something like that, before I was born. So it's older than me. So it's one of the very powerful space telescope. With Hubble, we got lots of interesting reason of the, like, the galaxy universe. So, but the thing is that Hubble telescope is not that big, and it is is visible is optics optical telescope, means that it will getting in the only the visible light. So the thing is that the very far galaxies, fast galaxies, as I mentioned, when the light are coming, it's coming to the longer wavelength. So it will go to infrared. So we will not able to see it. Our eyes only see the, or this Hubble will see the visible. So we cannot, they cannot see the infrared. So well, Hubble can see a bit of infrared, but it is not suitable for the fast wave. So the thing is that this wave, James Webb, that recently launched James Webb, so it's very powerful. It's the most powerful telescope ever in the space, and so it can trace to the fast galaxies. As you can see here, the limit is the fast galaxies. So the light from fast galaxies, it will reach to this Webb telescope. Really interesting, right? I mean, this is magic, very magic. So yeah, this is how we are going to study the fast galaxies, how the fast universe is, how the universe is at the earliest of the universe. Well, so now let's go. So we are sending the JWST, going like we are lifting to the JWST, and then just for comparison, I Hubble telescope. If Hubble telescope is like if it is like around the tractor, tractor that vehicles terror, then Webb telescope, it will be like Boeing 737 flight. So it means that it's too big, and it's like 2.5 times larger in diameter and 6 times in area. So JWST, James Webb Space Telescope, is 6 times larger in area than the Hubble telescope. Where's the Webb orbit? So yes, this is our planet. This is not to the scale. This is our planet Earth, and this is JWST, and the distance between our planet and the JWST is 1.5 million kilometer. This is the moon, so it's very far away from the Earth, and the Hubble telescope was around here. Hubble telescope was like it's a low orbit, but JWST. Why we keep the JWST as a longer? Because we don't want to interfere with the Earth's atmosphere, heat, or sun's, because JW2, the main agenda of JWST is to get the infrared light. So infrared is kind of heat map. So suppose if there is fire in the room, when we take infrared image, we will see the heat map. So we want to be cool. So the temperature of this JWST is like minus 235 Celsius. How cold is that? I mean, it's very, very cold, right? Minus 235. I mean, so it's very cold, and it's keeping away from the sun. So when the earth is low, when the earth is moving, JW is also moving. So yeah, and we need to, communication is important in everything. Communication is not only the telescope, it's everything. So for telescope also we need communication, right? So we instruct them to do okay, hello, say observe that galaxies or something. So we will get the information back. This is how we do talking with the web. So with powerful, we have with the technology, we have this DNS, and yeah, lots of things. So we, using the technology, we communicate with the James Webb, and so we are sending the instruction to observe that, and there we are getting data, we are analyzing, and we do the science. So as I said, JWST is studying the infrared light, not the visible light. Visible means we are visible, so they will, so more. Then why is that? Because I will play a bit small video. So when as I already explained many times, when the galaxies are expand further away, as you see, galaxies are, when they're light, they are visible. So we are going away further away, or we see in infrared. So because they are not, the lights are not moved to the like more longer wavelength. So we need this. And yeah, just I will not go deep into this. So why we need, because it's electromagnetic spectrum, they're very important, not only visible light, infrared light, microwave light, radio light. So this is one galaxy, Wilton galaxy. So when it's very hot, like in X-ray, gamma, lots of energy, we see the very like hottest region of the gas. And when ultraviolet in the ultraviolet spectrum, we see the young stars. And in the optic and our visible light, we see the star light coming from the star. And infrared. So here infrared is very important because uh, for in addition to the redshift, also it also will help us to get the uh, dust, like will help us to understand about dust, because when the light from the galaxies are coming, if there is lots of dust, it will absorb the light. So like, okay, yeah, I will come to that. And so this is why we need to use this multi-wavelength analysis important. And so for the well, it is as I said many times, it's infrared. And we have space telescope, which is also infrared, but web is more, good resolutions and the large. And yeah, so yes, the thing is that what web can do is that web can peer through and examine the dust with the visible light. When the suppose if there is dust, when we put the torchlight or something, like the dust will absorb it, and we will not see the light. So but in the infrared is that it can pass through it's longer wavelength, so it can pass through that dust. So like this. So this is a light from the stars is coming to, this is a dust means like it can be very small, like not our kind of dust, but it can be like carbon or yeah, some other things. So we call it dust. These are uh, and so when the light from the stars, when they pass through this it does, so it scatters the light bluer. So and the blue is shorter wavelength, so it transmitted to the radar. So we see the radar light, because we see in the infrared because of this scatter. So yeah, we as I said, uh, this JWST will help us to understand, observe the fast galaxy and the fast stars form. So yes, now we know why we need the JWST, because we need JWST is because it is the only telescope for now. We will give us the fast. We can observe. We can go back to the fast galaxies and observe it. So yeah, let's explore the universe. So are you ready? Let's explore the universe with the web. Fast, crisscrossing the early universe. Well, what is this realization? So what actually the James can do is that web can peer deep in space. Like we can go to the deep in space, capturing some of the fast galaxies that are formed in the universe. So as we can see here in this left figure, so this is the time of the reionization where the universe was very different place. Now universe is transparent. We can see the stars, we can see the planet, anything. But when the big after the Big Bang, some after some millions year after the Big Bang, we had very different form of universe. So the gas here, the gas between the galaxies was largely opaque to energetic light, so which make it difficult to observe the young galaxies. So yeah, we can, as you can see here, their light are obscure, like there is opaque to energetic light, so we are not able to see. But after some years become the transparent, like uh, transparent, like we see clear universe, as we can see here. Where is it? Can see, we can see here stars, galaxies, lots of things. So JW, why is that? I mean, what is happening around here? So we don't know before, I mean, we don't know much about this. So what JWST can do, can understand it. So can analyze the individual objects to understand how the surrounding gas change from the neutron to ionized, how they are changing. So this is one of the goals of the JWST. And well, fast galaxy, this is very interesting. Fast galaxy, I mean, we are going back to the 13 point after when the 300 years after the universe was formed, 300 million years after the universe was formed. And so by studying the galaxies over, like understanding this kind of, we will understand how they are changing. So for this, we need to understand the flip books of the galaxy over time. this is current galaxy, and the this is the like life cycle. This is let's say this is the first galaxy, and so what we can understand, what we can study with the JWST is that the galaxy's properties are changing. Galaxies are also forming stars, and some of the galaxies are not forming stars. And some galaxy collides, galaxy merge together, they fight, many things happening. So we will able to, if we like suppose if I want to know myself from the sign or when I was born, I need to keep track of what I was doing till from my when I was born till here. So by understanding how I was born to here, I will know myself more. So like that, we want to understand now. We need to go back and we combine every individual galaxies from starting past galaxy to till now. We will know how the galaxies evolve. So this is one of the major goal of the galaxy for the JWST. Then next is the black hole. Well, Webb can study the black hole. So Webb can peer through the obscuring dust to study the center of the galaxy. So our galaxy is the supermassive black hole Sagittarius A star. So JWST can peer through the this obscuring dust to study the center and the star that orbited. Not only this, we also can study the black hole for the nearby galaxy, nearby black hole to study the mass of the black hole and temperature, speed, composition, many things. So this is one of the major goal of the JWST. And next is the re-examining how stars form, live, and die. This is something interesting, right? I mean, this is how our planets are formed, how our stars are formed and die. So JW study will study many stars. So here, this is from the Carina Nebula from Hubble telescope. So here the visible light show the scorching radiation and the fast winds from super hot new stars. But the thing is that when we observe with infrared light, we see like here lots of new young stars are obscured by the dust. But now we can see lots of stars, right? So this is the powerful of the infrared. So this is, but Hubble telescope is not good enough for infrared. So JWST will help us to understand how the stars are formed, how they are live. And the next is the detecting the molecules in the star forming region. And this is important because we will able to understand the like molecular gas, how the like or like how to say, like star, like how the stars are forming and what are necessary conditions to make the star formation. And from here what kind of stars are like, what's the size, like depending on the molecule, like this star forming regions, what kind of stars are forming, and the molecular between the gas. So this kind of things, because the, that's our suns is forming like in this kind of things. But uh, there are lots of big, very large stars and the small stars, many different type of star, right? So uh, this kind of their origin is important, like how they are formed is so important. So JWST will help to understand this. And now it's re-examining our solar system planet. So JWST will not go for outer planet, outer like solar system. It also will help us study the about the say Jupiter, like Jupiter, then Mars, their atmosphere, and is there any water? Is there any like other like elements in the these planets? So and not only that, it also will help us to find the infrared, like find the distant planet. So in exoplanet, if there is there any planet, like is there any someone is there? I mean, aliens is there or something? I mean, but that is different thing. But JWST will help to discover new planets. So yeah, this is some of the major science goal of the JWST. And well, so now is the time for the reveal, like big reveal. So the JWST, after like it takes like more than 2 decades. Yeah, it was 2020, 2002 or something. Like yeah, it started commission for this JWST, and it takes 20 years, more than 20 years, and now finally it's in the space. And like it's unimaginable, like the technology or the men, uh, like how the engineering scientists are working on this is imaginable. But so let's see the reason of their hard work. Well, here, this is so, I still cannot get over with this image. So this is the web fast deep field image. It is a deepest and a dark surface infrared image uh, of the universe ever taken by the telescope, any telescope. And you can see here, very beautiful, right? So many of you are wonder why there is spark, like there is why there is spots with the spikes in the image. So these are the galaxies. This no, sorry, these are the stars in our galaxies. It's our like around our, like in our Milky Way galaxies. So this image, I would like to say that this image is just like when you grab the sand and put it here, like, so it's like very small, tiny regions, very small regions. So in this region, we see lots of like hundreds of thousands of galaxies. So what thing about if we observe very vast range of the sky, like let's think how many galaxies will be there. So this is the best, and it takes 12 hours for this to like 12 hours, yeah. And so there is very interesting object. I will not go in deep into because I don't have much time. So as we can see here, uh, some of the galaxies are just arc shaped, something like that. So this is the galaxy in the like, this marks 0723, which is around 4.6 billion year old. So this we are looking at this galaxies, this around these galaxies when they are 4.6 billion year ago, and around the around the time our planet started forming, our Earth. So due to the combined mass of this combined mass, this galaxy clusters bend the light from the background. So it's called gravitational lensing. What exactly is that gravitational lensing? Is that it was predicted by the Einstein theory of relativity. So the thing is that the galaxy cluster comprising the background cluster. So when they falls when the light from here reach this gravitational lens, so we s- it acts like a lens. So what we see is that uh, we see the lens images. So uh, here, this is just one galaxy, and so the light is coming from here, and this is light goes like this, and the light goes like this. So when it coming, we see kind of two images, two objects, but this is just one object. And yeah, these are the our some of them are nearby galaxies, and these are very far galaxies, like around 13 billion year old galaxies. So this is very yeah, this is wonderful. This is really one of the very I don't know how to say. And yeah, so with the Hubble telescope, and see what is the difference between the Hubble telescope and JWST. Hubble telescope takes 20 days to observe this. In JWST, they can do it like around some hours, and see how we can go deep. Thing about JWST used to like study for 1 days. We can see a lot of galaxies. This is the power of JWST telescope. Then next is that we can go to the reveal the planet. So this is a transmission spectrum. So we will able to understand when we study the when JWST also has other instrument called spectroscopy, and so it will take the spectra of the planet. So if there is water, we will yeah, this is how we came to know that this planet is WAPS 96b. It is 1150 light year from our planet. I mean, we observe the light. This is the first time we observe light. So this is a single object. So think about if the JWs are observing different analysis. So this is a preliminary reason we can study a lot. I mean, how about the level of water, many things. This is one of the yeah fast image of the JWST. Next is the planetary nebula. So yeah, this is what exactly is the planetary nebula. Planetary nebula is the like when the stars like our sun, when they die, they eject the outer surface of the their outer surface. So when they die, they just eject. So it's going boom. And so this is what we observe, and this is in the near infrared, as mid infrared. These are the hot. The interesting thing is that as if you see clearly, we see one stars which we cannot see here. So this is a dying star. This star is dying. So when this star die, as I say, their outer part are ejected. So and we see this hot gas and this what to say, this orange, this represent this orange who represent the newly formed uh, molecular hydrogen. And yeah, so with the JWST, we can clearly, detailedly study this kind of planetary nebula. And we can also study interacting galaxies. So this is one of the most powerful images. So this is like over more than 150 million pixel, which constructed with 1000 separate fine. So we see one, two, three, four galaxies at 100, around 200 millions light year, and this is around 40. This one is a nearby galaxy. It's beautiful. Like you can see gravitation tail, and these two galaxies are merging. Hot gas are spreading. Yeah. So yes, this surrounding, and this is how we can study detail, like minor detail. We can also see, like you see background galaxies, and we can study a lot from this galaxy, from this galaxies, because they are interaction. Like this is very important, because when our galaxies and the Milky Way galaxies and Andromeda galaxies, they are going to collide after some billions year later. So yeah, we can study these things. And here comes our interesting the star forming region of the Carina. So this is at around 7,600 light year, and so we can see here this is a very light. This is nearby galaxy stars, and here some new stars are formed. So beautiful. Here you can see some new stars are formed, and we have dust and the gas, and the stars here they push this dust and gas, and our this is how our solar system are formed. I mean, our suns are formed, our planets are formed, we are formed. I mean, so we are kind of forming this kind of, so we are connected, the atoms in our bodies are also kind of similar to atoms in here. So we are, as I usually say, we are stardust. So yeah, we are all connected to the universe. So this is how we can study. By studying this minor detail, we can study how the stars are formed, how the, and yeah, this is one of the interesting objects of the Carina Nebula of the, taken by the JWST. So as I taking more longer time anyway, so I'm going to finish. So web exciting discoveries are like they're trying to understand early universe. So web, the major goal is they try to understand the early universe and the galaxies over time, like starting to here till now, how they're changing, and the life cycles of the stars, how they are formed, how they die. And we can also study the exoplanet from outside our solar system. Is there any habitable planet? We can just go. Can we go there? Something like that. So JWST will be an excellent platform for snipping even aligned atmosphere. So here comes the last question: like, are we alone? Do you think we are alone in this universe? Because we are just small, tiny place in the Milky Way. In Milky Way galaxies, there are billions of stars, and so I don't think we are alone. But it will be hard to communicate with them, yeah, because of the distance. Hello, is there anybody out there? So yeah, anyway, thank you so much. So this is what the JWST mean, but only this 5 ms can sense the whole astronomy. So think about the future of the astrophysics. I think it's the best time for those who love astrophysics or astronomy. It's best time to go. He did go. This was, we have we have exciting futures everything for us. So new era of astronomy has begun, and we cannot wait to see what the web reveals next. Yeah, thank you so much.
All right, so thank you, Ronaldo, for the interesting conversation. So, yep, I hope that our audience learns something new. And even though it was, I mean, even though it was a little lengthy, but yeah, we understood a lot of things. I mean, that is the most important, right? Instead of the time, so we understood a lot of things about how you all explain about the various phenomena and also what is occurring in the night sky, all the different simulations and videos which you showed, they were really, I mean, say, I mean, that
Yeah,
just
I'm
this
sorry
this is
because
awesome.
yeah, because of this time scale, I cannot go deep into many other things. So sometimes I speak more further because of the time. Yeah, I'm sorry for that, but I think we cannot cover this in 1 hour because I can speak this for many hours. So yeah, but this is really interesting. I cannot stop. So yeah, thank you so much. Yeah.
All right, so thank you so much for that. And all right, so guys, in case you have any questions, feel free to mention them in the chat section. We would take up a few of the questions since, yeah, I think we can extend a bit because we have also started a bit late. So yeah, I think we can go ahead about like 2-3 minutes as well. All right. So well, thank you so much for that. So till the time you guys are mentioning down your questions, there are a few things which I have in mind as well. So that is that but how long does it usually takes for a space telescope to be built and launched?
Well, yes, it depends on the telescope because for JWST it takes like more than 20 years because because it need to be cooled down. We use lots of new technology like keeping the temperature at minus 235. It's very hard. It's not impossible, but it will take lots of the material which we are going. So yeah, it depends on what kind of telescope, and it usually take lots of time because we also need to put it in the space, and we need to set up many things. So for JWST, it takes 20 years plus. Yeah.
All right. So okay, that is well quite a lot of time, but yeah, I think the amount of how do we take up time and we build something this new, so that is, I think that's pretty good as well. Okay, so we have a question in the chat about black holes. Yeah, we'll take that question in a moment. All right. So, all right. So, thank you so much for answering that question. And that is, all right. So, can we, through the help of JWST, can you also observe the near worlds such as planets and asteroids in our solar system through JWST?
Yes, as I also shown, like we can study the planets and yeah, we can study the planet and about the asteroid, we can, but the major goal of the JWST is not to observe asteroid because for asteroid we can use other telescope like because we JWST is too efficient for the asteroid, and so yeah, but we can observe it because like whatever is farther away from the JWST, if by my telescope is there, I can observe whatever is outside of mine. So, but we the goal of the JWST is not to observe the asteroid for now. Yeah, but
Okay.
planet for our, like Mars and the Jupiter and the other planet, they can. Yes.
All right. So, that's perfect. And thank you for answering that question. All right. So, okay. So, do you seem to know that what are the next space telescopes which are already in the queue, and how will they enhance the field of astronomy?
Yeah, actually, for now, according to my knowledge, like yeah, there are some. Even our India also that planning for some space telescope, but yeah, I need to check out that properly. But yeah, not much for now on the pipeline. But we need more because, as I say, our Earth atmosphere they restrict the light from the like gamma ray. They only visible lights and some part of the radio lights are coming through us. So if you want to observe in other, as I saw image in other spectra, we need to be put our telescope in space. So we need more telescope there, to see how our universe is formed. We need a cosmic microwave background. This is a fast light from the universe of the Big Bang. So this is in the microwave spectra. So we need to go to the space, but we already have telescope for that. Yeah, we need more telescope, to see more detail of the galaxies, and yeah.
All right. So, thank you for answering. Okay. So, we have a good question in the chat, and that is by
Yes.
Muhammad Janzeb Khan, who's asking that JWC got a damage recently. So, how fatal is it? And
Okay.
okay, is there only one JWST?
Yes. So there's only one jet because it costs 10 billions USD and it's too much. And yeah, and only one. And the question is that yes. They are recently not, we cannot say not dim, but it was struck by the micrometeorites, but it will not affect the, it will not must affect the science because JW was prepared for this. But the thing is that the problem is that if lots of micrometeorites are started hitting, then we may be a bit worried about the lifetime because JWT lifetime we are expecting more than 20 years for more. So yeah, for now nothing fatal. Yes.
All right. So, okay. So that's a good thing. I would say that there is nothing fatal as well. All right. And all right. So now that comes to another question, which is a little irrelevant, but I think it's a good question. That is that do black holes pull dark matters?
Well, that is one of the major goal of the JWST. So yes, actually we, yes, because dark matter, we don't observe the dark matter, but dark matter interact with the gravity. So even the black hole, the black hole, it's like everything's not matter, one matter, everything's goes that deep. I mean, are so I think so, but I'm not black hole expert, but I think yes, they pull dark matter, but I'm not expert of the black holes. But even we don't know much about this one, so JWST will help us to understand more about the black hole. Yes.
Okay. So well, let's see what we are expecting, and yep, let's see how good we go
Yes,
ahead.
we are expecting. Yes, see how the future interesting.
Yes. All right. And okay, so do we have any other questions? Okay, so guys, if you have still have any questions, feel free to mention them. I mean, astronomy is huge; it's just vast field of ocean. There are so many other things, starting from black holes to dark matters to I don't know, so many other things. But yeah, I think that is something which makes it furthermore interesting and good to research upon and study upon as well. So well, thank you for that. And all right, so all right. So we have explained about JWST and how special is it, and we have almost come to the end of today's session as well. So before or there's something which I'd like to ask, and that is, do you have any book or movie recommendations from us, which which inspires you or which you want us to read or
Yeah,
watch?
I mean, so there are lots of books or movies. Like I will go for movies. So like I think most you should watch Interstellar. I think most of you watch the Interstellar movie. It's one of the Christopher Nolan, one of the best, my favorite. And we have this Martial, and we have this Gravity, and the Contact. Contact and so it's very inspiring movie. So these are some of the movies and books. Yeah, lots of books uh, this theory of everything. I mean, Stephen Hawking and every history of time and a parallel universe by Masio and yeah, I mean there are lots of books. So yeah, there's lots of interesting books. So I can recommend those things. So and those are not difficult to read. I mean, they don't put the most physics, mathematics term into that, so you can easily understand and go for it. Yeah.
All right. So thank you so much for the book and movie recommendations. And I believe that the audience must have seen a few of them and read about them as well. But yeah, that
Yeah.
is something really great. And okay, so that is also fantastic. All right. So okay, so we have gone a little overboard as well. So yep. Um, yep. So I think yeah, that's completely fine because yeah, we can see that how interesting this topic is. So. Uh, Yep, that is awesome. And even if it goes over, it's still fine because it's still interesting. And there is still so much more to learn, which obviously cannot be comprehended or which cannot be stuffed into just an hour. And as you said, that you can go on for hours and hours about astronomy
Yeah,
and
I mean,
explaining about this.
I prepare for this for 30 to 40 minutes, but still I cannot keep track of because I was in the slide. Yeah, I mean, I can go for this hour and hour because this is just I only give the very small part because I cannot go for everything, right? But there are lots of things to say and explain, or it's it's never ending. I mean, it's really you should there are some articles for that. I mean, without the physics, not without the physics background, but just for the what is going on. So I think I recommend you to go for it. And we are stardust, so we should understand our origin. I mean, not even you are from arts or whatever. we are made from, our atoms are from the stars. They die for
All right.
us. So yeah, astronomy is for
Okay.
everyone.
Got it. Got it. And since you already mentioned that you already do coding, so what else do you use coding for when you are in this for
Oh, do you
astronomy
want,
itself?
to see it? I mean, I play with the image. I can play it
Uh-huh.
a bit, but I don't know whether how the time is going on. I don't know. Or later. I mean, what I did is, uh maybe, okay, I can share the video probably. Let's see, because I got it, and 1 minute. I will just share the video so that
Yeah.
anyone can, for only for 1 minute. So some seconds. So yeah.
Okay. Sure. I mean, I would love to see that as well.
So it's just like,
Mhm.
but this is not big deal. I mean, I just, because I didn't sleep a whole night, and I was like very excited. So yeah, I
All
put
right.
the video. Can you put it? Yeah.
Yes, definitely. I'll just quickly put it onto the screen and okay, it's loading. All right. All right. Yep. There you go.
So there is like, I do the calling. I can play if I move the sounds, but this is not the real sound. But you see, depends on the, if there are lots of galaxies there, it will give us more sound, because if we go there, you see my hand, right?
Oh, oh, wow. I mean,
You see that my hands are moving whenever I move like this.
yeah. Okay, so basically, whatever your hand is touching, it's being converted into sound, or is it?
Because it depends on the image,
Yeah.
because I'm
Uh-huh.
assuming this is any image. This is, I'm assuming my version, like image is there.
Yeah.
So if
Right.
there, suppose if there are lots of galaxies here, there are lots of
Right.
objects, or it means that more pixels are there. It is there. So if I go there, it means that more
Mhm.
pixels. So it give us a more sound, more, like, if we
Okay.
convert the pixel will be converted to sound. So if I go
All
into
right.
here, say void, no galaxies, the sound will be very less, because there is the pixel value is very small. So yeah,
Okay.
this is
Uh-huh.
how I play with the
All right. All right. So, okay. So, I mean, so correct me if I'm wrong. So, all those spaces where we can see a lot of bright objects, so there the sound would be more, right? Or the frequency would be
yes,
more, correct?
yes,
Right.
yes, yes, because the pixel is more. I mean,
The
the
pixels
image
is
is
more.
all pixel. Yes, yes,
Yeah.
yeah,
So wherever the pixels are more, the sound would be more, and if the number of stars are, at a particular place, so the frequency would be more because there are more
yeah.
number of
So it's,
stars, right?
yeah, and
Okay.
it's good. Even it's not real sound, but it looks like real sound. I going to the space, touching the sky. Yeah,
All right, so that is okay. That's fantastic. I mean, I love it so much. Okay, thank you so much for showing this video. And I mean, okay, thank you. I mean, I asked, so that's why we're able to see this so well. Thank you for that. And do you have any other cool things? I mean, I would love to see some more. If you're uploading some of them, so I think that would be fantastic. And I think the audience would also love this because this is really good. I mean, how you're converting that same image into sound frequency based on the pixel value, right? I think the
yeah,
RG and
yeah.
the three pixel
Yes,
values, which are
RZ, yes, those pixel values, and yeah, image are, these values are there. So yes, that's interesting. I mean, but it's not real sound. I would like to clarify that that is not real sound. That is just, but it looks it. Yeah, it feels like real sound. Yeah.
right. Okay. So I think with this we have come to the end of today's session because since we cannot see any more questions in the comments as well, and I think yep that would be it. So all right, guys. So thank you so much for attending this particular webinar, and I hope that you all have learned something new and also must have been awestruck by all these images and the super cool things which is done by Mr. Ronaldo from sound to a lot of other simulations and the rest of the things. This all just super interesting stuff. So I hope that you all loved the session as well. And we hope to see you guys again soon. Subscribe to YouTube if you're on YouTube and follow us on LinkedIn if you're on LinkedIn so that you won't miss any other such super cool, awesome stuff. All right. So till then, everyone, stay tuned. And well, once again, thank you, Mr. Ronaldo.
Yeah, it's very
All
nice.
right,
Thank you so
everyone.
much. Okay,
Thank you, everyone. And
fall in love with the astronomy. I would like to say this is time for the astronomy. Yeah,
all right. All right,
okay,
everyone. So take care, everyone, and have a great day or a great night ahead. All right.
thank you.
Bye, everyone.